Mining is a key activity that propels India's economic growth. But this activity comes with its fair share of risks: blasting, flooding, collapses, fires. In this episode, we explore the risks involved in mining as well as safety precautions in place to make the whole process safer. Now, these risks have even inspired stories in Bollywood, with their inherent drama and catastrophic value. But the reality on the ground can actually match this drama. Like in Dhanbad, the heart of India's coal mining area. It is one of India's oldest and most productive coal mines. Mining here started way back in 1894. But this is also home to some of the longest burning coal fires in the world. You can only see the smoke because the fires are actually raging underground. The first fire started in 1916, so they have been burning for over 100 years. Shocking as this sounds, it's not an uncommon phenomenon. There are many underground coal fires like this one raging around the world. And there is a reason for this. Coal catches fire easily. Now, this can be because of external sources of heat like lightning or forest fires. But equally, it can happen with no external stimulus. The result for this? Spontaneous combustion. As the name suggests, it means that coal can start to burn without any specific outer influence. This is caused by coal's ability to react with oxygen present in the air. As a result of this oxidation process, the temperature of the coal starts to rise. Now, if the temperature reaches a certain level, noxious gases are produced, such as carbon dioxide and hydrogen, both precursors to combustion. Then, as the temperature climbs further, coal reaches flash point and starts to burn. And these fires are difficult to put out. This is because when coal is hot, it has a massive thermal mass, which makes it very hard to extinguish. Which is what has happened in Jharia. There are more than 70 fires that burn in this region. And these fires have an economic, environmental, and social impact. More than 100 crores of dollars have been lost in this region. Also, 1.5 metric tons of coal is inaccessible because they're blocked by fire. This is a huge hazard for the people living in this area. The underground fires in Jharia have even created sinkholes, which are basically cavities in the ground caused by erosion. And these sinkholes can swallow people.
कोयला का आग को बुझाने के लिए आपको मेनली या तो वहाँ से कोयला को हटाइए या वहाँ से ऑक्सीजन जाने का रास्ता बंद करिए। तो चूँकि आग नीचे है, ज़मीन के नीचे आग है, तो उसमें ऑक्सीजन जाने का रास्ता बंद करना डिफ़िकल्ट हो रहा है। उसमें आप क्या कर सकते हैं, ऊपर में डोजिंग करके उसको ऊपर मड फ्लशिंग करके उसमें बंद कर सकते हैं, या उसमें पानी का इंजेक्शन कर सकते हैं, या मेन जो सबसे अच्छा तरीका है उसमें इस एरिया को डिकोल्ड करना पड़ेगा। सारा कोयला को पहले आपको हटा लेना पड़ेगा।
Before we study the issue further, let's understand a little bit more about mining. Mining is the removal of geological substances, essential minerals from either soil or sand. These minerals can be metallic or non-metallic. Our country is a rich source of minerals of both kinds. According to the Indian Ministry of Mines, India produces as much as 87 minerals, which include 4 fuel, 10 metallic, 47 non-metallic, 3 atomic, and 23 minor minerals. 80% of mining in India is coal, since over 65% of India's power supply is generated from coal. And the balance 20% is in various metals and raw materials such as gold, copper, iron, lead, bauxite, zinc, and uranium.
In our country, we have mapped a part of our country only at a shallow depth. But a large part of our country still has not been mapped, and it is said by the expert geologists that our mining geology is almost similar to the mining geology of countries like Australia, Canada, where the major minerals are produced.
Our economy, or any other economy for that matter, cannot survive without minerals and the products made from them. Take any average person's life. Everything from beauty products to electronics to transport systems are made possible because of mining.
If we look at the contribution of mining in our GDP, it's around 1.5%, somewhere in between that. The potential is what? If we look at the developed countries, it is up to 10 to 12% also. But if we look at our country, the potential could be 8 to 9% in the next 2 to 3 years' time.
Now, how do we tap this potential and extract these minerals from the ground? In surface mining, the ore is accessed directly from the earth's surface. Giant machines are used to remove the top layers of soil and bedrock to expose the ore. After the ore is exhausted, the soil and rock are returned to fill the mine. The area is then revegetated and can be used for other purposes such as cropland, wildlife, recreation, or industrial use. Surface mining is commonly used to extract coal and copper, and increasingly precious metals like gold. A big downside of this method is the massive ecological impact. In underground mining, the bedrock is kept intact and tunnels are used to access the ore. Deep vertical tunnels called shafts are drilled into the ground, along with a set of horizontal tunnels called drifts to access the ore. Some underground mines require elevator shafts to remove miners and ore to and from the surface. Underground mining is used for gold, platinum, zinc, lead, and increasingly coal. Here, though the environmental damage is less, there is a higher potential for injury and a higher use of labor. Both methodologies have issues, but clearly the risk is way higher in underground mines. Let's break it up a little bit. Explosions are a huge risk. These usually happen in coal mines where either the methane gas or the coal dust leads to the explosion. One of the biggest explosions in India was the Chasnala mine explosion that took place in 1975. The explosion was so severe that the mine collapsed and millions of gallons of water from a nearby reservoir rushed into the pits. And then there is a risk of waters flooding the mine. This is what happened in the Baddi mines in Jharkhand in 2006. Floodwaters gushed into 5 mines in this area, causing about 64 casualties. Another common risk in mines are collapses. These cave-ins can happen because of excessive excavation or as a result of the gradual sinking of the land, which is what happened in 2016 in the Lal Matia colliery in Jharkhand. A mountain of earth fell from an open-cast mine, killing 23 people and injuring many others. This was the most deaths to take place in an open-cast mine in India.
In underground mining perspective, the major the hazard which are involved are the fall of ground, the risk of fire in underground. Since the mechanization is on the upfront, so we have got machine-machine interaction is one of the hazard, or machine-to-man interaction is one of the hazard.
Besides this, long-term health problems are a serious job risk as well. We will look at this in more detail later in the episode. But first up, let's explore some structural solutions that could improve safety in mines. We travel to the Hindustan Zinc Mine in Rajasthan to see how some specific threats can be addressed. Take, for example, the risk of structural collapse. A rock bolt is used to stabilize the excavated rock. These bolts are arranged in such a manner as to transfer the load from the unstable exterior of the rock to the stronger interior part of the rock. Sometimes, a resin capsule is inserted in a hole on the roof, which will then act as a binding agent. This resin helps hold the bolt in place. A steel mesh is then installed that offers protection to the miners from the loose scaling in the mines. After the meshing is done, it's time for the third step, shotcreting, which is basically the application of concrete at high velocity. This is done on the roof of the mine to increase the load carrying capacity and hence prevent collapses. Flooding is another huge risk in underground mines. What are the steps that can be put in place to stop flooding? In this mine, they use pumps to remove water from inside the mine. Once groundwater is detected, a small hole is made so that water can drain out of the area. Now, this water is collected into sumps which act as makeshift ponds. Now, dewatering pumps are installed to take water out towards desilting tanks on the surface. This way, they avoid water seeping into the ground, decreasing its stability. The wastewater is treated and recycled in mining processes like wet drilling. This helps in saving water and so has clear environmental benefits. We've explored some of the hazards and safety mechanisms in underground mines. After the break, an in-depth exploration of surface mines. Let's move away from underground mines to see some of the hazards in surface mines. Now, in open pit mining, narrow strips of land are cut into the side of the mine. These are called benches. One of the big risks here is the stability of the slopes. If not properly constructed, this could lead to a collapse. The width and height of the bench should be checked properly. In most cases, the width should be less than the height, and the face angle of each bench should be kept between 55 and 80 degrees. Slope stability radars or SSR radars are used to monitor the displacement of benches on the wall. In this case, since the mine is oval-shaped, radars on both walls are used. These radars move 180 degrees on their horizontal axis and 100 degrees on their vertical axis, thus providing maximum coverage of the benches.
इसके अंदर में लेज़र बीम के द्वारा रेज निकलती है और बेंच के ऊपर में जाके स्ट्राइक करती है और लौटती है। इसके लौटने का टाइम और इसकी वेलोसिटी जो रहती है उससे इसका जो होता है डिस्प्लेसमेंट को मेजर करते हैं और पर्टिकुलर डिस्प्लेसमेंट जो हर सेकंड पे आता है उसको दूसरे अगले सेकंड के साथ में कंपेयर किया जाता है, तो उससे डिस्प्लेसमेंट के अंदर में जो वेरिएशन आता है उससे सरफेस का मूवमेंट का पता लगता है।
The radar can monitor a displacement in the range as small as 5 millimeters. This is then highlighted with a green marker in the monitoring station. In case a particular area gets more than 50 green markers, an alarm is raised and mining operations are suspended. Mining in a particular area can sometimes continue for more than 100 years. And so benches can lose stability. To increase their stability, high-tension steel wires are used. First, a hole is made. Then these wires are inserted and it's finally compacted with concrete. As you can see, there are many wires at different intervals. These wires hold the loose walls and bind the rocks together. Just how steel bars and rods are used during construction. Now, blasting is also essential in mining. It is used to fracture rocks, giving access to minerals, but it has its risks. Hazards from blasting arise when the area is not secured or when there is fly rock that can hurt people on the site. Of course, there are also issues when there's a premature blast or a misfire. But with the right protocols in place, which is not difficult, this does not pose an enormous risk. What is a constant risk for all miners is health issues, which is what we're exploring after the break, so keep watching. In our journey through mining disasters, an enormous risk in most mining sites is the risk to health due to constant exposure to dust, noise, and vibrations. To look at these in more detail, we head to the National Institute of Miners' Health in Nagpur. Experts here are working to better the health of miners and reduce what are now considered occupational diseases. Dust is a huge problem in most mines. Inhalation of coal dust can cause what is colloquially known as miner's lung or black lung. Symptoms here include shortness of breath and scarring of lung tissue, which can cause ongoing respiratory problems. Blasting and drilling leave very fine mineral dust particles in the air that can accumulate in the lungs. This buildup can lead to pneumoconiosis, a disabling, irreversible form of this condition known as silicosis can develop when a miner inhales large quantities of crystalline silica or quartz, which is found in sand, clay granite, and many other forms of rocks. In order to reduce this dust in mines, constant water spraying can be done, especially in areas where heavy vehicular movement is happening. Most of the drilling done during mining activity like this is done along with water. This is called wet drilling, which results in the minimal suspension of dust in the air. Also, to keep the air fresh, there are long ventilation pipes with huge fans at the entrance of many mines.
Apart from that, we are measuring the dust. The area sampling is being done with the gravimetric dust samplers, and even the personal dust samplers are being given to the people where the dust levels are high potential and dust levels are there.
This is also one of the issues that is looked into at the NIMH.
So we have the facility for monitoring the dust concentration in the respirable mine air. So the breathing zone, we monitor the breathing zone of the worker by fitting the dust monitors.
Another area of work is silica analysis. Silica, as we have seen, is one of the most harmful components of dust.
Silica in crystalline form, if you are inhaling that as a part of your occupation, then it can cause a deadly disease called silicosis. So we must know it is not only the amount of dust that is in the air, but also the silica content in that dust. We have the monitoring and risk assessment facilities for that in NIMH.
Another big issue in mines that affects the health of most miners is vibrations and noise. Vibration is a hazard that occurs with the constant use of certain heavy machinery, which is very common in mining. Constant exposure to these vibrations leads to a syndrome called whole body vibration, which has symptoms that include musculoskeletal disorders, vision impairment, as well as cardiovascular change. Unfiltered noise emanating from equipment can also lead to temporary or permanent hearing loss, speech interference, as well as eardrum rupture. To understand the scale of noise in any area, the Director General of Mine Safety instructed all mine owners to do a noise mapping of their respective mines. This is basically a pictorial depiction of how noise is distributed over an area.
It is not only a monitoring of noise, how you are exposed to noise, or how a particular area is categorized as noisy or very noisy. It's not like that. It is how the noise is distributed over an area, entire area, and whether the noise that is being generated by the mining operation is extending beyond the lease boundary and then affecting the community.
Now, what can be done to reduce or prevent noise? To reduce the high-level noise impact on miners' bodies, often machines can be insulated in cabin. Many miners are also given heavy-duty earplugs to reduce the effect of the sound. The damage is not only to miners' health. In many cases, mining has a huge impact on the environment also. During the process of mining, harmful substances can be released into soil, air, and water. Mining also leads to deforestation, destruction of habitats, soil erosion, disruption of the watershed, as well as pollution.
If you go into the Jharkhand, which is one of the key coal mining states, the entire Damodar river stretch has been identified as severely polluted because of various industrial activities, but a key component is also mining. That happens because there is a lot of runoffs.
Let's look at how does mining affect our water systems. When miners upturn earth, minerals and heavy metals seep into the water table. This increases the risk of chemicals contaminating the groundwater and acid mine drainage. Mining also lowers groundwater levels around the mine. This is because, in order to remove some minerals like coal, vast quantities of groundwater must be pumped out of the mine. As a result, surrounding ecosystems and farmland may become drier, and erosion may start to change the landscape. When mines lower groundwater levels, this also affects local people, who must continuously drill deeper wells to get water. There are ways of countermanding this too. The first possibility is to do an environmental analysis before the setting up of a mine. This could help control the damage done. But this can only work while setting up new mines. In the case of existing mines, one way of mitigating the issue is by managing the site better. This could include managing waste, replenishing the soil, planting vegetation on the site, reusing scrap innovatively, and improving efficiency. These will not make the process green, but will definitely help in reducing the environmental impact. This kind of thought and care could change the way the industry grows, which it will. Since mining is a critical industry that will bolster India's ambitious growth plans. So safety regulations, effective disaster mitigation, skills development, and a concern for the environment are key to make the sector both safe and productive.